Okay, look at example 2. The slight difference between examples 1 and 2 is a division sign instead of a multiplication sign. And again, you don't want to do division of fractions. You always want to do multiplication of fractions. When you're dividing, what you're dividing by is the second fraction. So I need to invert this fraction to change it into a multiplication problem. So again, if I see that problem in my book, what I'd write on my paper is a multiplication problem. I wouldn't even copy that problem out of my book. I would just copy it onto my paper as a multiplication problem. And x squared minus 6x plus 8 is going to stay right where it's at, because the first fraction is not being divided, so it's going to stay as is. And x squared plus 3x minus 28 is going to stay on the bottom of that one. Then when I get to this fraction, x squared minus 2x minus 15 is going to go to the bottom. And x squared plus 2x minus 35 is going to go to the top. Again, a lot of times algebra is about what you want to happen, and there's some kind of way to make it happen legally. So I don't want to do division of fractions, I want to do multiplication of fractions. That's fine, but the consequence is this fraction has to flip over. Okay. Once you get the structure as it should be, then we're going to, again, just factor everything. And once again, we got a bunch of quadratic trinomials here, so it's just the same type of factoring you did on the first one. Negative 2 and negative 4. Negative 2 plus negative 4, so x minus 2, x minus 4. For the red one, positive 7, negative 4, 7 minus 4, so x plus 7, x minus 4. For the purple one, positive 7, negative 5. And of course 7 minus 5 makes the positive 2. For the green one, negative 5 and positive 3. And negative 5 plus 3 makes a negative 2. So we factor everything, basic quadratic trinomials again, so same factoring. Again, if you get stuck, if you can't think of one way to do it, just go ahead and do a chart and you'll find it. Typically, I can't remember a problem like this where they didn't just work, where they didn't factor at all. So, you know, expect if it's got a power bigger than 1, it's going to be factorable in some way, shape, or form. Next, again, we look for common factors. Anything the same on top and bottom is going to be dealt with. So this x minus 4 matches that x minus 4. This x plus 7 matches that x plus 7. This x minus 5 matches that x minus 5. The only requirement is something's on top, the same exact thing's on the bottom. It doesn't matter what fraction you're in, whether they're the same fraction or in different fractions. As long as there's one on top, one on bottom, you can cancel. And then again, we're multiplying. These don't match, so we can't cancel them. All that's left on top is x minus 2. All that's left on bottom is x plus 3. And we leave our answer like so.